Hi all, welcome back to our channel Vision Board, and today we will discuss about the time complexity. So please note this one, the time complexity is very important if you become a expert coder. Okay, so what is time complexity? The time complexity is a really confused one for the working professionals and the students who are studying in BTech, BCA, MCA, but we can crack it if you have a if you eager to learn this, we can definitely crack it. It is very important because what I will tell you, what I'm telling, this is very important. There are some coding site you already know, HackerRank, Greek for the Greek. So all the coding sites, they have the measure of the time complexity as well as the space complexity, because the purpose of that site is to become an or generate some of the students into an expert coder. So the expert coder means, or efficient coder means, they can able to do the coding with the faster code, with the faster code and the space with the less space, right? So this is the importance of time complexity. So already we discussed about three type of complexities are there: best case, average case, and worst case. So in this notation we will discuss about time complexity. So today we will discuss about the measuring the actual running time is not practical. So before lesson we discuss about the data structure, how it work and all, and the measuring the actual running time, because if we implement one data structure in a high performance machine and try to run it, it is not possible. So this is not possible one. And the second one is the running times depend on the size of the input. That also we know, right? The array size is increasing, that much time it will take. So that is also there is a dependency. For example, so we can know the f of n represent the instruction executed input to value. That means f of n is a function that will execute n times. Okay, for example, you can see, I will tell you how it works. Or f of n is the function of n denote the time complexity. That means the function f of n, how many times it will execute, that means that much of time it is consuming. Here you can see that for I in n, that means, for example, n equal to 10, how many times the print wall statement will execute? 10 times, right? That means if you assign one point or 1 unit time for this statement for executing the first one, for I equal to 1 time, 1 unit, so up to n time it will execute, right? So that what will happen there? What will happen? That 10 second or 10 unit of time will need. But the same scenario you can consider as thousand of element or one core of element. Okay, what will happen? One core time will take to execute. That means it is huge, right? So the time is increasing. So that is the function f of n is increasing. That means time complexity is also increasing. Time complexity means how much time it will take. Time complexity. So here you can see that f of n equal to n, that means n times that loop will execute. Okay, the print instruction execute n number of times, so f of n equal to n. Then how to find f of n? But this is also a very tricky question. How we can find the f of n? Is it easy? Because every time we take this one and find it, it is not possible, right? Not. We can compare two data structures for a particular operation by comparing them for f of n values. That is the one thing. And we are interested in the growth rate. We already know growth rate means how a graph will growing. So this is the one we are considering. Growth rate means how the graph will or time will. Depends upon the number of function, how the time will increase. So time will increase, what happened? Time complexity also increase. That means the worst case, the program is going to worst case. So that is the growth rate of the f of n with respect to n, because it might be possible that for smaller input size, So one data structure may seem better than other, but larger input it may not. So there are some dependencies. So we will discuss it. You just focus. We will discuss another thing. It's an easy way. So this concept is applicable in comparing two algorithms as well. For example, f of n equal to 5n square plus 6n plus 12. So this is the one function. That means that one function contain. I will tell you how this expression we get. So you can see here I have all the note in my hand, but for your knowledge I will tell you how it comes. You can see here the consecutive element. There is a program n equal to 10. Okay, and the sum I assign to 0. First loop will execute I equal to n, means 1 equal to first loop iterate 1 to or I to n. The statement will execute. And the second loop is a matrix. For example, you just remind second will be the matrix. So we need two group, right? Two nested group for I equal to n and for j equal to m. So here we considering each one statement take execution time is 1 unit. So 1. This statement also 1. But this for loop how many time iterate? N time. So the iteration value will be n. But here you can see that first for loop n time and the second for loop also, nested for loop also n time. That means the total complexity of this function means n square. So how we can find time complexity of the total program? So 1 plus 1, 2i here. The complexity of this one n, and the complexity of the nested, the time taken for the nested is n square, n into n. So this is the one. This is a quadratic equation. So this is the happen I am writing here also. You can see here I took a program contain two nested for loop or anything, for loop and one for loop plus 12 statement. So this is the total time. The total time will take the entire system, entire program. So we need to find, for example, n equal to 1. This is the first thing. The percentage of running to due to 5n square. We need to find how much time will take each of the tape. How much time will take this one, how much time will take this one, how much this one. So this is our question. The first one is we are taking the percentage of running time due to the 5n square. So what will happen? 5 divided by 5 plus 6 plus 12 into 100. That means 21.71%. Next one is percentage of running time is 6 and how much time this time is considered? 6 and equal to 6 by 5 plus 6 plus 12 into 100. That means 26%. You still remember n equal to 1. The first only one element. Okay, only one element in the, we need to iterate only one element. So percentage of running time due to 12 is 12 divided by this. So this is the higher for n equal to 1. But the twist is that it will be changed. When the input size of n will be high, it will definitely change. I will show you. So you can see here, right? So this is happened here. F of n equal to 5n square plus 6 and 12. For example, an input array size is 1, then 21%, 26% and 52%. But if the number of array is equal to 10, what will happen? Means n into n square, 5 into n square, 100. Okay, this term will change. You can assign n equal to 10 here. So 87. Here you can see 6n is 10%, 12 is 2%. If it is n equal to 100, what will happen? 98%, 1%, 0.02%. If it is 1000, what will happen? 99.8%, 0.12, 0.0002%. What will know? Because the input array size, if the input array, that means n number is increases, n into n. That means square. It is we cannot compare the square with the n and the constant, right? So this is the growing term. So we can see that this is the growing fastest growing term with the input. Okay, number of n is input. This is the first. That means if we, for example, if you take this is 1 lakh, okay, or 1 lakh, 1000 or 1 lakh, what will happen? So 90.99% time will consume this one to implement, as compared to that time this also negligible. So we can avoid this one. For the larger values of n, the square term consume almost 99% of time. So we can remind the neglecting terms. So leading constant, that means this one 12, 6, that we can delete, and lower order term n. This is this is n, right? Here you can see that n also lower order. Here is a constant. These two terms we can neglect. So the graphical representation you can see here, f of n, this is f of n function and the n. The first time, this is the constant term. We already see the first thing. You already see the first time starting the n, the constant term will consume the majority of the time, right? This also take the time. This is lesser. But if the number of input in the increases, that will happen. That means initially the constant is high value, but it will be reducing. And the next one also, the linear, that also reducing. But the n square value is increasing faster, but it is starting less, but it is increasing, depends upon the number of input, the squared. So this is the one it happen. So total function of f of n 5n square. We neglected the remaining 6n and 12. We neglected because there is no impact on that part. We are getting the approximate. We are getting approximate time complexity. Okay, we are focusing on the approximate time complexity, not because actual time complexity it is not possible. So what we can do, we are taking the approximate time complexity. We are satisfied with this result because of the approximate result. It is very near to the actual result. So the approximate measure of the time complexity is called the asymptotic notation or asymptotic complexity. So this asymptotic complexity contains omega, theta and a big O notation. So that we will discuss in the next lesson, and the big O notation I will discuss on the next lesson. Then bye.